All right, we have spent a lot of time graphing sine and cosine. So hopefully by now you feel comfortable with it, because we're about to transition graphing sine and cosine into graphing secant and cosecant. So we're going to jump into problem number 1. And problem number 1 is cosecant. So first thing I do is I am going to recognize that cosecant is the reciprocal to the sine curve. And so I'm going to make a little note to myself, and these are the same notes that I've been doing for a long time with sine, right? It's the amplitude, period, phase shift, and vertical shift. So amplitude for sine, 1. Period for standard sine, 2 pi. Phase shift in this case is none, and vertical shift in this case is none. Now, how does that relate to cosecant? So cosecant, I'm going to put these notes off to the left. So amplitude, period, phase shift, and vertical shift. Out of everything we've written down, 3 of them are identical. The period is 2 pi, the phase shift is none, vertical shift is none. Now, this is where it becomes a little weird. Cosecant and secant do not have an amplitude. It does not exist. It is not defined. It doesn't make any sense. So it is not applicable. It's NA, or none if you wanted to write that too. All right, and I'll explain why once we've actually drawn the graph, so you can see visually why there is no amplitude or why it doesn't exist. So what I'm going to do is I am actually going to draw just the critical values for my sine curve. So on my x-axis, I'm going to go ahead and mark out 4 units. I'm going to label them like I would normally. So 2 pi, pi over 2, 3 pi over 2, right? All of that's normal. And I'm going to do X marks the spot for sine. So sine normally starts at the origin, goes up to 1, back to the midline, down to -1, back to the midline. All right, so these are my critical values. Now, what I need to remember is that cosecant is the reciprocal to sine. So I need the reciprocal of all of these critical values. The easy one is all of these midline values. All of these midline values are 0, and the reciprocal to 0 is undefined. So everywhere sine has a critical value on the midline, cosecant has an asymptote. So I'm just drawing in some asymptotes here. Okay. Now, the other part that is 100% true is the reciprocal of 1 is 1. So cosecant actually has a point at 1, and the reciprocal of -1 is -1. So cosecant has a critical value at -1 as well. So I'm going to zoom in on just the graph here, because I want to talk about what's happening to the sine curve versus the cosecant curves. So if I were to draw in the sine curve, and we've done this a bunch of times, the sine curve looks like this, and that's just one period. So from this critical value heading towards the left, sine is decreasing towards 0. As sine decreases towards 0, these decimal values are getting increasingly and increasingly smaller. As the reciprocal, those values would become increasingly large to the point that they approach infinity. So where this sine curve curves down to zeros, the reciprocal function, the cosecant function, curves up to infinity. Now you can't cross vertical asymptotes, okay? So you got to stay within these bars, but this is going to keep getting closer and closer to the asymptote, and it's going to keep increasing till forever. Now, we can do the exact same logic for the negatives. So as we get move to the left from this critical -1 value, we're getting closer and closer to 0 through these negative values. And same thing on the left, the right side here. So as sine is approaching 0, cosecant is going to be approaching infinities. Now, I am going to eliminate, I'm going to delete or erase my sine curve in there because only the purple curves here are your cosecant curves. Now, this is just one period. Obviously, we could continue. So you would have, where would I be? So over here, I'd, whoops, let me actually write with a pen here. So I'd be up at 1, curve to infinity, curve to infinity. And then I could continue, I can reflect it, not reflect it, but continue it to the negative side. So sine would have its next critical value down here at -1. And we would have a vertical asymptote here. And so we can just keep drawing this. So I want to revisit really quickly why I said that amplitude does not exist or it's not applicable. Amplitude is defined as the distance to the maximum or minimum from the midline. Now, our midline in this case, I'll use the red highlighter here, is the x-axis. Okay, great. The problem is we don't actually have maximum points because these curves are approaching infinities. Whether it's positive or negative infinity, you're approaching an infinity. So you can't define a distance with infinities. So cosecant and secant do not have an amplitude. Sine and cosine do because they have a maximum and a minimum point that you can find the amplitude between those. All right, so that is the basic cosecant curve. I'm going to go ahead and slide over to number 2. Let's do the same kind of idea with the basic secant curve. So secant is the reciprocal to cosine. So if I do my normal amplitude, period, phase shift, and vertical shift, and yes, I almost always answer these things because it helps me graph stuff. Amplitude's 1 for cosine, all right? Phase, no, that's period. So period is 2 pi. Phase shift in this case is none, and vertical shift is none as well. So how does that help me with secant? Well, the amplitude would be NA, right? It's not applicable to talk about amplitude for secant. Period, it's going to match. So whatever this cosine curve is over here with 2 pi, it will match. Same thing with the phase shift and vertical shift. So phase shift, none, and vertical shift, none. So I am going to do a little X marks the spot on my graph to get the cosine curve in place. So 1, 2, 3, 4. Let me zoom in just a little bit. So 2 pi, pi, pi over 2, 3 pi over 2. Cosine starts off center high. So 1, midline, -1, midline, +1. Now, we're going to do the exact same process. Any place that cosine has a critical value on the midline, you are going to have a vertical asymptote. I just wanted to thin out that line a little bit. There we go. Okay, so there are my 2 vertical asymptotes for this particular graph for the period. Your cosine curve and your secant curve will share the minimums here and the maximums. Okay, but where cosine, and I'm going to draw a quick cosine curve. So right here, where cosine is approaching 0, right, this value is dropping down to the midline, it's approaching 0, that's the cosine curve, which means that the secant curve is going to be approaching infinity, okay? And then between our next critical values here where this hits -1, Cosine goes from 0 to -1 back to 0, which means that secant would be coming from infinity. It's going to hit -1 and then go back to infinity, in this case negative. And the last part of the cosine curve is the 0 up to, hold on, let me actually get a curve here, 0 up to +1. So that would be for secant from positive infinity to 1. I am going to delete out the cosine curve that I drew in because it is not needed. In fact, you need to get rid of it. Apparently I got rid of my eraser there. Okay. So that is one cycle of the secant curve. If you wanted to see what it looks like when you continue it, these will curve back up. So that will become the other half. You would have a vertical asymptote. I thought I thinned that up, but that's okay. A vertical asymptote here and did thin it out. Let's try and keep it that way. And a vertical asymptote here. And so you could continue the curve moving left and right across your graph as you need to. All right. So that is a lot of time getting just the basics of the secant and cosecant curves. If you have any questions or concerns, let me know. I'm going to go ahead and close the video on the 2 basic graphs. I'll do another video that gets into some of the problems where you actually have period changes and phase shifts that you'll have to deal with. Let me know if you have any